Algebra 1. In this video we are looking at Unit 7, Lessons 4 and 5. So Lesson 4 is solving quadratic equations with the zero product property. So example 1, what values of the variables make each equation true? So for this first one, if you do 6 plus 2a equals 0, and then subtract 6 from both sides, you get 2a equals negative 6, divide by 2, you get a equals negative 3. For the second one, 7b equals 0. If you divide by 7, 0 divided by 7 is 0, so b equals 0. For the third one, there's two ways to do it. So if you do 7 times the quantity c minus 5 equals 0, and you multiply both these out, you get 7c minus 35 equals 0. And then add 35. 7c equals 35, divide by 7, you get c equals 5. Or, if you do 7 equals 0, so your 7 right here equals 0, and your c minus 5 equals 0, and add 5, you get c equals 5. And if you do 7 equals 0, that does not work, so that is not 1. So it would be c equals 5. And then for our last one, it would either be g equals 0 or h equals 0. Here is example 2. Find the solution or solutions. So number 1, x minus 3 equals 0. So if you add a 3 to both sides, you get x equal to 3. Number 2, you would subtract 11 on both sides and get negative 11. Number 3, 2x plus 11 equals 0. So if you work this one out, you would subtract 11 from both sides and then divide by 2, and that will give you negative 11 over 2, and don't worry about reducing that into a decimal. For the next one, if you do it like our last one on the last slide and do x equals 0 and 2x minus 11 equals 0, you get x equals 0, and just like this last one, the 2x minus 11, that gave us negative 11 over 2, so it would be 0 and negative 11 over 2. For the next one, you put each of the parentheses equal to 0 and get 3 and negative 11. And then number 6, you put both of them equal to 0 and you get 3 and negative 11 over 2. And then for the last one, you'll have 3 answers. You'll have 0, negative 3, and 4 over 3. And you just put each one equal to 0. So your x equals 0, your x plus 3 equals 0, and your 3x minus 4 equals 0. And then solve. Here is example 3. We have seen quadratic functions modeling the height of a projectile as a function of time. So here are two ways to define the same function that approximates the height of a projectile in meters t seconds after launch. Which way of defining the function allows us to use the zero product property to find out when the height of the object is 0 meters? So that would be the one with the quadratic expression in factored form. And number 2, without graphing, determine at what time the height of the object is 0 meters. So here we would put our negative 5t minus 3 and our t minus 6 equal to 0 and solve. And then when you do that, the negative 5t minus 3 equals negative 3/5, but a negative value does not make sense in this context. So our t minus 6, which gives us t equals 6, so our height would be 0 after 6 seconds. Here is lesson 5, which is how many solutions. Example 1, decide whether each statement is true or false. So the first one, 3 is the only solution to x squared minus 9 equals 0. So that is false because you could do negative 3 squared and you would still get 9, and that minus 9 is 0. The second one, a solution to x squared plus 25 equals 0 is negative 5. That is false because you cannot square a number and get negative 25. So even if you did negative 5 times negative 5, you still get a positive 25, and that plus 25 would not be 0. Okay, for the next one, x times a quantity x minus 7 equals 0 has two solutions. That is true. That would be 0 and 7. And then the last one, 5 and negative 7 are the solutions to x minus 5 times x plus 7 equals 12. That is false because the product of the two factors is not 0. So this would be false because this isn't a 0, it's a 12. Example 2, Han is solving 3 equations by graphing. So number 1, to solve the first equation, x minus 5 times x minus 3 equals 0, he graphed y equals x minus 5 times x minus 3 and then looked for the x-intercepts of the graph. Explain why the x-intercepts can be used to solve this. So the solutions to x minus 5 times x minus 3 equals 0 are x values that make the expression have a value at 0. And for b, what are the solutions? If you put each one equal to 0, you would get 5 and 3. Number 2, to solve the second equation, he wrote it as x minus 5 times x minus 3 plus 1 equals 0, and then he graphed y equals x plus 5 times x minus 3 plus 1. So use graphing technology to graph that equation, and then use the graph to solve the equation. So I already graphed this, and we would use the x-coordinate of the x-intercept, which is 4, so that is our solution. Number 3, solve the third equation using Han's strategy. And so that would be y equals x minus 5 times x minus 3 plus 4. So if we graph that, there is no x-intercept, so there are no solutions for this. And then number 4, think about the strategy you used and the solutions you found. Why might it be helpful to rearrange each equation to equal 0 on one side and then graph the expression on the non-zero side? So when a quadratic expression is equal to 0, we want to find the unknown values. We can think of it as finding the zeros of a quadratic function or finding the x-intercepts of the graph of that function. And then number 2, how many solutions does each of the 3 equations have? There are 2 solutions for the first equation, 1 solution for the second one, and no solutions for the last one. Here is example 3, solve each equation. So number 1, x squared equals 121. Take the square root of each side and you'll get x equal 11. Number 2, x squared minus 31 equals 5. Add 31 to each side and then take the square root and you'll get x equal to 6 and negative 6. Don't forget the negative 6. Number 3, you'll get 4 because they are both x minus 4. And if you set that equal to 0, you'll get 4. Number 4, x plus 3 and x minus 1 equals 5. If you do 2 plus 3, that's 5, and negative 4 minus 1 gives you 5. Number 5 does not have solutions. You can try and work that one out if you'd like, just to see what you get. And then number 6, x minus 4 and x minus 1 equals 900. You'll get 34 and negative 29, and the work for that one is right up here. So if you do 34 minus 4 and negative 21 minus 1, you get 30 for each of those, and 30 times 30 is 900. Here is example 4. Number 1, consider x minus 5 times x plus 1 equals 7. Priya reasons that if this is true, then either x minus 5 equals 7 or x plus 1 equals 7. So the solutions to the original equation are 12 and 6. Do you agree? So no, because it only works if the product of the two factors is 0. And then number 2, consider x squared minus 10x equals 0. Diego says to solve, we can just divide each side by x to get x minus 10 equals 0. So the solution is 10. And Mai says, I wrote the expression on the left in factored form, which gives x times x minus 10 equals 0, and ended up with two solutions, which is 0 and 10. Do you agree with either strategy? So we would agree with Mai's strategy, because by substituting 0 for x and 10 for x, you can see that they are both solutions. Diego's strategy eliminates one of the solutions, which only leaves one solution, so you're missing one of them.